Hello viewers, so let's solve this problem together. We have 3 to the power of 2x plus 2 plus 27 to the power of x plus 1 is equal to 36. Let's recall when I have a to the power of m plus n, this is the same as a to the power of m times a to the power of n. So splitting these numbers here, we have 3 to the power of 2x times 3 to the power of 2 plus we have 27 to the power of x. So we have 27 to the power of x plus 1 is equal to 36. So for here, we have 3 to the power of 2x times 3 to the power of 2 plus our 27 3 to the power of 3. So we have 3 to the power of 3 further raised to the power of x plus 1 is equal to 36. So when we have a to the power of m further raised to the power of n, this is equal to a to the power of m times n. So we'll be multiplying these powers here to have 3 to the power of 2x times 3 to the power of 2 plus 3 to the power of 3x plus 3, and this is equal to 36. So we have 3 to the power of 2x times 3 to the power of 2 plus 3 to the power of 3x times 3 to the power of 3, and this is equal to 36. We have 3 to the power of 2x times our 3 to the power of 2 is 9. We have 3 to the power of 3x and our 3 to the power of 3 is 27, and this is equal to 36. 9 is common here. We'll factor out 9 from here to have 3 to the power of 2x plus we have 3 to the power of 3x times 27 divided by 9, we have 3, and this is equal to 36. So we can divide through by 9 to have 3 to the power of 2x plus 3 to the power of 3x times 3 is equal to, we have 4. So we can split these powers here to have 3 to the power of x further raised to the power of 2 plus 3 to the power of x further raised to the power of 3 times 3, and this crossing over here we have minus 4 is equal to 0. So let our 3 to the power of x be equal to a. So at 3 to the power of x, we have a squared plus we have a to the power of 3 times 3 minus 4 is equal to 0. So we have a to the power of 2 plus 3 times this, we have 3a cubed minus 4 is equal to 0. So rearranging this cubic equation, we have 3a cubed plus a squared minus 4 is equal to 0. So we are going to be solving this equation. So we'll factor out 3a squared to have a left here, and we have minus 1 here, plus when we factor out 4 from here, we have a squared minus 1, and this is equal to 0. Our a squared minus 1, which is this, is equal to a minus 1 times a plus 1. So this is difference of 2 squared. We have 3a squared times a minus 1. We have plus 4. So this value will replace it with a minus 1 times a plus 1 is equal to 0. So when we factor out this value out, we have a minus 1 and we are left with 3a squared plus 4 times a plus 1 is equal to 0. So we have a minus 1 and we have 3a squared plus, when we open up this value, we have 4a plus 4, and this is equal to 0. So this simply means that a minus 1 is equal to 0, and 3a squared plus 4a plus 4 is equal to 0. So we have a to be equal to 1. So we've gotten the first value of a. So from here, let's check if our discriminant will give us a complex number. We have d to be equal to the square root of b squared minus 4ac. So we have d to be equal to, our b is 4. So we have 4 to the power of 2 minus 4 times 3 times 4. So our d is equal to the square root of 16 minus 4 times 3 times 4. We have 48. So d is equal to square root of minus 32. So we have a complex value here. So let's work with a to be equal to minus 1. Our a is equal to 1. Now let's recall that our 3 to the power of x is equal to a. We have 3 to the power of x is equal to 1. But 2 to the power of 0 is equal to 1. And 3 to the power of 0 is equal to 1. Our 3 to the power of x is equal to 3 to the power of 0. So our x is equal to 0. Thank you for watching to the end of this video. Subscribe and hit the notification bell so you don't miss out on any of our solutions.